Hello everyone, my name is Arman and we are going to do Math 120, Discrete Mathematics 1 this semester in a flex format, meaning that the format is in a way that I'll record the videos and lecture videos and then I will upload them on Moodle. Discrete mathematics is one branch of mathematics, important branch of mathematics, which mostly deals about counting problems, if I want to describe it in a simple way. And so in this course, and it's related, of course, to, it's a branch of mathematics itself, and it's very much related to computer science as well. So for this reason, most students in computer science need to have a basic knowledge of discrete mathematics, or even advanced level knowledge of discrete mathematics if they want to pursue a higher advanced level degree in computer science. So in this course, the topics that we will cover, are the topics that not just discrete mathematics, but also topics related to discrete mathematics, which are very much useful and essential in mathematics and also in computer science, such as basic logic. So that's where how we will start this course, by going through basic logic. Many people in my experience think that mathematics is mostly about numbers, dealing with numbers, and properties of numbers and things like that. So of course, yes, numbers are important in mathematics, but more important than numbers is logic. Basic logic, the statements, the conditional statements. If something happens, then a conclusion, for example. So for example, if it's a Monday, then I go to the mall, for example. So this is a conditional statement. Or for example, if x is equal to 2, then 2x is equal to 4. So these are, but we'll go over them, these are examples of conditional statements. But generally, logic, if, for example, P implies Q, can we say that Q also implies P? So understanding, the concept of statements and basic logic is the essential foundation of mathematics, more important than numbers. Okay, so we will go over, and also in computer science as well, in computer science also, you have to know the basic logic. Even in also for the philosophy, in philosophy, you also need to know basic logic. So basic logic, not just in these fields, even in daily life, like I said, many examples we can consider in basic logic deals with daily life. So we'll go over basic logic in this course. And the other topics that we will cover will be set theory. Well, set theory is sets, basically, and the properties of sets is also a very essential foundation, a fundamental element of mathematics. What are sets? What are the operations on sets? What are their properties? Again, this field is very important in mathematics and also in computer science. So these are, like I said, fundamental elements of both mathematics and computer science. So these are the foundations. I'm sure you are familiar with sets and properties of sets, but we'll go into more details. And the other element or topic that we will cover is methods of proof. So you are I think, familiar with proofs a little from previous courses. Even in Math 100 pre-calculus, you have some statements to prove or some exercises for proofs that you have to prove simple things. But here in this course, we want to go over formally, we want to go over different methods of proof. For example, direct proof, proof by contradiction, and other methods. So, for example, in pre-calculus, you saw that you can prove that root 2 is an irrational number using proof by contradiction. So in this course, we will go over all methods of proof and with examples, of course. So again, this is a very fundamental element of all mathematics, not just discrete mathematics. In any branch of mathematics, you need to prove statements. So you have to be familiar with methods of proof. Also in computer science, especially theoretical computer science, you need to prove things. So this is also very important. Then we will go over some basic number theory. So number theory itself is a different branch of mathematics. Normally is not considered as a sub-branch of discrete mathematics, but in this course, it somehow can be considered because it involves numbers on integer numbers, which can be also considered as discrete set. But normally it's not considered a sub-branch of discrete mathematics. But in this course, we will go over some basic introduction of number theory. So for example, properties of integers, division algorithm, prime numbers, or a fundamental theorem of arithmetic. So that you have some idea about number theory. But of course, if you want to go into more depth, you need to take a number theory course, which we currently don't have it in the college, but you can take it in, for example, UBC or SFU, basic number theory. I think normally it's considered a third year level course. And we'll also do fundamentals of countings, which is what really discrete mathematics is about. So like I said in the beginning, discrete mathematics is mostly about counting problems. For example, combinations, permutations. For example, let's say this class, I think currently around 15 students have registered. So let's say if I want to choose 2 of them for some reason, let's say, I don't know, let's say some gift, for example, or something. Let's say I want to choose 2%, or let's say, for example, choosing as TA, for example, any type of reason. Let's say I want to choose 2 students out of 15 students that we currently have. So in how many ways can I do this? So let's say if I call this student number 1, 2, 3, all the way to 15. So for example, I can say that I want to choose student number 1 and 2, or 1 and 3, or 2 and 10. So there's so many ways, right? So exactly how many options do I have to choose 2 students, let's say out of 15 students? Or in another scenario, maybe the order is also important for me. So one scenario is that, let's say I want to choose 2 students, let's say to choose as TA. Then both students have same role, so the order is not really important. But what about, let's say, if I want to choose one student as, let's say, main TA and the other student, the assistant to the main TA? So then the order is also important. So in that case, in how many ways can I choose 2 students? Okay, so these are just some simple examples. And this topic is also very much related and important for if you want to take probability theory course, Math 206. So this topic is very helpful there and essential when you, especially discrete probability. In probability theory also can be categorized into two branches, discrete probability and continuous probability theory. So in the discrete probability, you need to know about counting problems and how to perform or solve counting problems. So that's another topic that we'll cover in this course. And also we'll cover relations and functions. So you are familiar with functions from high school or at least from pre-calculus. You know that function is a rule that assigns exactly one output to each input, right? But functions can be considered as a special case of a mathematical object called relations. So cover relations, definition and properties of relations, and then functions and the definition and properties of functions. Of course, some of them you have seen before in high school or pre-calculus. But we'll also in this topic, we'll cover equivalence relations and partial orderings. So ordering, so right now I'm sure you're familiar with the ordering of ordering that we have for real numbers or for integers. For example, we can say 1 is less than 2 or 2 is less than 3. So this is an ordering that is defined on integers or real numbers. But what about if you want to define an order on some other type or of some other mathematical objects other than numbers? For numbers, it's obvious how to define ordering. But let's say if I want to compare, in other words, if I want to compare two other mathematical objects, for example, two functions or two vectors, how can I define an ordering for those type of objects? So we'll get the idea from the ordering that we define, an obvious order or trivial ordering that we have for numbers. We will use that to define or provide a formal definition of ordering, which can be applied for other types of objects, mathematical objects. So these are basically the topics that we'll cover in this course. So I told you very briefly about it. And of course, then if you want to know about other important topics in discrete mathematics, then you can also, after this course, you can take Math 221, Discrete Mathematics 2. And in that course, you will learn about other important topics such as graph theory. Graph theory itself is also a very important branch of mathematics and also computer science, very much related to computer science. Because, you know, for example, let's say when you deal with data, let's say, for example, Facebook users, and whether there is a friendship between the Facebook users or no. So that can be considered as a graph, and the users can be vertices of the graph, and then the friendship between those could be considered as edge between those vertices. So these are the terms that is used in graph theory. Is not a topic of this course, but if you're interested, you can take, after this course, you can take Math 221, Discrete Mathematics 2. Okay, so let's also go over, I've uploaded the course outline on Moodle. So hopefully I've I looked at it so far, but let's go over it quickly again. So let me share my screen. Okay, so these are some basic information about the course. So this is the YouTube channel. You know, you can find the videos on my YouTube channel. And the office hours, Monday, Thursdays, 8:30 to 10:30. Feel free to come to ask any questions about the lecture, especially because it's a flex course. I think it's very important that you attend the office hours to ask any doubts or questions that you have from the lectures or from the prerequisites. So prerequisites of this course, as you know, are Math 100 with B or 113, 114, 115 with a C. So I told you about the course briefly and what we're going to do. And this is a textbook, Discrete Mathematics and its Applications by Rosen. And make sure that you get the right edition, which is 8th edition. Because, you know, for the homework, I'm going to use this edition and refer to the page numbers and question numbers. So it's important that you have the right edition so that you'll be referred to the right questions. So I told you about the topics that we're going to cover in this course already. And then for the tests, we'll have 3 tests, 3 midterms, and 1 final exam. Each midterm will worth 20% and 1 final exam 40%. And the total will be 100%. So these are the proposed dates for midterms. October 1, 22, and November 12, from 8:30 p.m. to 10:30 p.m. So if any of these dates or times do not work for you, please let me know by end of Thursday, September 9, and let me know why these dates or times do not work for you, or what type of modification you would need so that the dates and time would work for you. Yeah, but please try to accommodate and, you know, like make sure that, you know, that the times work for you. If there are things that you can do so that you can make these work, please do so. But if something important you have something, you know, that is really important and you can't make them work, then let me know. And for the test, so basically I wrote the instructions here. So it's important that you go over the instructions carefully. But the idea is that all the tests will be closed book. Basically the way that we conduct them is that, you know, I'm going to read the questions out loud for you. So that takes usually around 10-15 minutes. And then during that time, you're allowed to look at the screen to make sure that you copy the questions correctly. But after that time, after you copy the questions, then you are not allowed to look at the screen anymore. And you have to just look at your own paper, and you will not be allowed to use any electronic devices such as laptop or phone. So you have to just look at your own paper, and the exam will be closed book. And then you have usually around 1.5 hours to write your test. And after that time, I will ask you to scan your exam, take pictures and scan your exam and convert it to one PDF file, which you can do so by using the Cam Scanner app or a similar app, and upload it on Moodle. So that takes also around 10 minutes. So around 15 minutes. And by the way, another important part of the exam is that you basically setting up your webcam. So it's important that you set up your webcam correctly in a way that, you know, basically your face, hands, and papers and surrounding and the surface in front of you. So let's say if you're sitting on a floor, the surface of the floor has to be visible. If it's on a bed, the surface of bed has to be visible, and so on. So it's important that you set up the webcam correctly. So I will check the webcams and then read the questions out loud for you. So this takes around 15 to 20 minutes. And then 1.5 hours, you have time to write your test. And then 10 minutes at the end of the exam, you have time to scan your exam. So the total time for all this process will be around 2 hours. But for writing the test, you have around 1.5 hours. This is for the midterms. For the final exam, the total time will be 3 hours, and you have around 2.5 hours to write your test and half an hour for the rest. And I'll also send some sample pictures before the test one about setting up the webcam, because as I said, it's very important that you set up the webcam correctly. And then for homework, I'll upload homework weekly on Moodle. So make sure that you do them for your own practice. Basically, you don't have to hand in them. It's just for your own practice and to get prepared for the tests. So basically, most questions in the test are either similar to the things that we did in the class, so similar to lecture notes, or similar to the assignments that I upload on Moodle. So most questions are similar to one of these two sources. And if you miss an exam, you will not get any point for it unless you submit a doctor note within 1 week after the test. So please make sure that you follow this instruction. And classroom code of conduct and cheating plagiarism policy. So these are common for all college courses. I'm sure you're familiar with it, but please go over them again. And the grading system. So the grading system also same as other courses, UT courses, and I'm sure you're familiar with it. Yeah, so please let me know if you have any questions about the course outline or any questions about the test or test formats. Okay, so I'm going to stop share here. And we can start the first chapter. Okay, so let's start with the very first chapter. So chapter 1, logic and proofs. So we'll start with the first section, which is about propositions. So what is a proposition? Well, proposition is a declarative statement, or declarative, let me say, sentence, declarative sentence, which is either true or false. So any sentence that can be categorized as true or false, and it's declarative, so it's not a question, for example, it's called a proposition. So a proposition is denoted by P or Q or R, S, etc. Okay, so let's look at an example. So for example, a statement which can be said or determined as true or false. So for example, each week has 7 days. So this is a proposition. So this is a proposition. which is true. Okay, but if we say, for example, each week, so another example, each week has 8 days. So do you think this is still a proposition or no? So this is still a proposition, but this time a false proposition. So this is a proposition which is false. Another example, so we said if I ask a question, then that cannot be considered as a proposition. So for example, will you go to the mall? So this one is not a proposition. So these examples are not mathematical examples, but we can of course consider mathematical examples as well. So for example, let's say if I say, let's say 2 plus 2 equals 5. This is a proposition which is false, right? So it still is a proposition, but it's false this time. Okay, now another example, let's say 2x equals x plus 1. So do you think this is a proposition or no? So in order to answer this, we have to know whether this can be determined as true or false or no. So in most examples we saw, well, they can be determined as true or false. But for example, when I said, will you go to the mall? So this cannot be said it's a true statement or false statement. So that was not a proposition, but the rest were propositions. What about this one? 2x equals x plus 1. But we know that this is a very simple linear equation, and we know that this equation holds and is true only for one value of x. You know, you can easily solve for x is equal to 1, right? So only if x is equal to 1, this is true, and otherwise it's false. So I cannot say whether this is true or false because the value of x has not been specified. So this statement, whether it's true or false, depends on x, but x has not been specified. So this one is not a proposition because there's nothing being said about x, and therefore I cannot say whether this is true or false. So this is not a proposition since the value of x has not been specified. Okay, but if I say, for example, let's say if x is equal to 1, then 2x is equal to x plus 1. Then this is a proposition which is true. Okay. All right, now we need to also know about operations between propositions. So we can connect propositions together with operations. You know, when we learn about numbers, for example, first we learn what numbers are, then we learn operations between two numbers. Now here also we learned about propositions. What is called a proposition. Now again, similarly, similar to for the case of numbers, if I have two propositions, I can connect those two propositions with an operator. So that is called a logical operator. So logical operators. So given two propositions, let's say P and Q, one can connect those using a logical operator. Okay, what are the operators now? So the first operator, so here are the list of important logical operators. So the first one is negation. So what is negation? So the negation of a proposition P denoted by negation P is a proposition which is true if P is false and is false if P is true. So P, remember, is a proposition, therefore it's a declarative sentence. So negation P means it's not the case that P holds. So for example, if I say P, so let's look at an example. Let's say P is, it will rain tomorrow in Vancouver. Then negation P will be, it will not rain tomorrow in Vancouver. Right? So if it's rains tomorrow, then P is true, negation P is false. If it doesn't rain tomorrow, then P is false, negation P is true. So negation P, like we said, has the property that if P is true, negation P is false. If P is false, negation P is true. Okay, so another example, let's say P is 2 plus 2 equals 5, which is a false statement, right? Negation P will be 2 plus 2. So like we said, negation means it's not the case that P holds. So if it, in other words here, I should say it's not the case that 2 plus 2 is 5. So the mathematical notation for this sentence is 2 plus 2 is not equal to 5. So P is 2 plus 2 is equal to 5. Negation P will be 2 plus 2 is not equal to 5. And like we said, if P is false, we expect negation P to be true. And it is the case here. 2 plus 2 is not equal to 5. And that's true. Okay, so this is the first operator. Okay, then the second operator is called conjunction. So again, we have two propositions and we want to connect them with an operator to obtain a new proposition. So like I said, similar to numbers, if you have two numbers and you can add them to get a new number, right? So in that case, addition is an operator that performs between two numbers. Here we have two propositions and we want to perform an operator called conjunction between those two. So given two propositions P and Q, the conjunction of P and Q denoted by P and Q is the proposition which is true if both P and Q are true and is false otherwise. And is false otherwise. Okay, so basically this conjunction is like an and. So if I say sentence one, let's say I have two sentences and I want to connect them with an and. So sentence one and sentence two. So this overall sentence will be true if both parts of this sentence one and sentence two, are both true. And if one of them is false, the overall sentence will be false. So normally, in this topic, we can show the truth values of this, compound proposition. So this type of proposition is called compound proposition because it consists of two or more smaller propositions. So the truth values are normally denoted by a table. So that table is called a truth table, right? So truth table so the truth value of a compound proposition can be determined, or I can say represented, can be represented with a table called truth table. Right? So the truth table looks like this. So let's say I have P here, for example, Q, and then P conjunction Q. So in this table, we have to record, all possibilities, truth values for P and Q and P. And for each case of truth values of P and Q, we have to record the truth value of the compound proposition. And in this case is P conjunction Q. Okay, so what are the possibilities for truth values of P and Q? Well, P could be true or false. It's a proposition, so it could be true or false. Q is also a proposition, so it could be true or false. So each of them have two possibilities. So overall, we have four possibilities. So this could be true. So both could be true, or this could be true, this could be false. or this could be false, this could be true, or both could be false. Now, in each of these cases, we have to determine the truth value of the compound proposition, in this case, P conjunction Q. So we said that conjunction is like an and. If I say sentence one and sentence two, when can I say overall sentence is true? Only if both of them are true. So only if both of them are true, then P conjunction is Q is true, and then otherwise the truth value will be false. Okay, so let's look at an example. Let's say if I say P is that so let's say I will watch a movie tomorrow. Q could be, let's say I will eat chicken tomorrow. So P and Q, right? P conjunction Q will be true only if I watch a movie and also eat chicken tomorrow. If I do both of these acts, I watch a movie and eat chicken, then P conjunction Q will be true. Otherwise, for example, if I watch a movie but I don't eat chicken, then P conjunction Q, the overall will be false. So P will be true, Q will be false, and P conjunction Q by definition is false. Okay. For another example, let's say 2 plus 2 equals 4, and 2 times 3 equals 7. So is this true or false? This overall or compound proposition? Well, let's look. This consists of two parts. 2 plus 2 equals 4 is true. So the first part is true. 2 times 3 equals 7 is false. So first part is true. Second part is false. So overall is false, since 2 times 3 equals 7 is false. Okay, so one part is false, so overall is false as well. Now the next operator, 3. So remember, we are studying operators between propositions, which can help us to connect two propositions to find a bigger proposition, which is called compound proposition. So we have looked at negation and also conjunction. Now let's look at disjunction. So again, given two propositions, P and Q, the disjunction of P and Q denoted by P or Q, normally we say P or Q, is the proposition, or compound proposition, which is false if both P and Q are false, and is true otherwise. So this is the opposite of this conjunction situation. That case, we said it's the compound proposition is true only if both of them is true, otherwise false. This one we say it's false if both of them is false, otherwise it's true. So in other words, conjunction is usually false unless both of them are true. This one is usually true unless both of them is false. Okay, so which is false if both P and Q are false, and it's true otherwise. So the truth table, let's first look at truth table. The truth table, again, you have P, Q, P, or Q. So this one could be true, or both could be true. True, false, false, true, and then false, false. So if both of them are true, this will be true. If one of them is true, this is still true. And it will be false, like we said, by definition, it will be false only if both of them are false. And otherwise, it's true. So let's look at an example. So we said 2 plus 2 equals 4. This time, let's say we say or. So this is like an or. If we say sentence 1 or sentence 2. When can I say that the compound sentence is true? Well, even if one part is true, the overall compound sentence is still true. It will be the overall sentence is false only if both parts are false. So if I say, let's say I remember the example we said, I eat chicken tomorrow and I'll go to movies or watch a movie tomorrow. Let's say if I do one of these acts only, for example, I watch a movie, but I don't eat chicken. So still, if I say I'll watch a movie tomorrow or I'll eat chicken. So even if I do only one of them, the overall and compound sentence is still considered to be true because there is or between them. Or like in a mathematical example, if I say 2 plus 2 equals 4, or let's say 2 times 3 equals 7. So previously we said if there is a conjunction or and between them, the overall will be false because one part is false. But this time, 2 plus 2 equals 4 or 2 times 3 equals 7. This is true since 2 plus 2 equals 4 is true. So for disjunction, again, only one part is enough to be true, and then the overall compound proposition will be true as well. Okay, so then, and there is another operator called exclusive or there is also called XOR operator. Again, given two propositions, P and Q, the proposition P, the proposition P exclude XOR Q. So this is the notation for exclusive or XOR. P exclusive or Q is the new proposition again. So this is the notation. So plus with a circle around it. It's just a notation, for this operator is true. So you can read this. Read P X or Q. So this proposition, this compound proposition is true only if exactly one of P or Q is true and the other one is false. Okay, so this is the truth table for this case. So again, see we have P, Q, and then we have P XOR Q. So this could be again true, true, this could be true, false, false, true, false, true, and then we could have both false. Okay, so if both of them are true, P XOR Q will be false. So let's compare it with this case. When we say P disjunction Q, we just require at least one of them to be true. So whether exactly one of them is true or both of them true, we don't care. In any case, we say the disjunction is true. But in the case of XOR, we really care that and we require that exactly one of them must be true, not at least one of them. Exactly one of them must be true. So if both of them is true, it's not desirable for us, and we would say that the PX or Q will be false in this case. But if exactly one of them is true, like the second case here, or the third case, we say PX or Q is true. And if both of them are false, again, we would say it's false because we require exactly one of them to be true. So if both of them are false, still the compound proposition is considered to be false. Okay, so for example, again, 2 plus 2 equals 4, XOR 2 times 3 equals 7 is true, right? Because exactly one of these two statements, 2 plus 2 equals 4 and 2 times 3 equals 7, exactly one of them is true, which is actually the first one, right? 2 plus 2 equals 4 is true, but the second one is false.